Hello, everyone, and welcome to part 4 of our introduction to risk assessment. This is GCU from the University of Minnesota. Today, we will focus on exposure assessment, which is a critical step of the risk assessment process. So, what is exposure assessment? It's the process of measuring or estimating the magnitude, frequency, and duration of exposure to a chemical or other agent. It also considers the characteristics of the exposed population. There are several key elements involved in this process. We start by identifying the source of exposure, for example, a chemical release from a manufacturing facility. Next, we consider the pathway, such as whether the agent moves through air, water, food, or soil. And then the route of exposure, meaning how it enters the body by inhalation, ingestion, or dermal contact. We also need to consider a few important factors. The concentration of the chemical, such as micrograms per liter of water or milligrams per cubic meter of air. The duration of exposure, whether it's acute, meaning short term, or chronic, meaning long term. The frequency, how often the exposure happens. And finally, the population characteristics, such as age, job tasks, and specific behaviors that may influence exposure. This information helps us understand the potential for harm and informs the next steps in the risk assessment process. Overall, the goal of exposure assessment is to understand how, when, and how much substance reached people. In this slide, we introduce the concept of potential dose, a key step in assessing exposure. The dose is calculated using this basic formula. Dose equals the concentration of the chemical multiplied by the intake rate divided by the body weight. Once the potential dose is calculated, it helps us understand or determine the type of health effects we're concerned with. If we are looking at non-carcinogenic effects, such as liver or kidney damage, we use the average daily dose, or ADD. But if we are evaluating carcinogenic effects, meaning the potential for cancer over a person's lifetime, we calculate the lifetime average daily dose, LADD. This distinction helps guide which health endpoints are relevant for risk characterization. In this slide, we focus on average daily dose, or ADD, which is used for assessing non-carcinogenic effects. When we are calculating ADD, we only consider the period during which exposure actually occurs, not the full lifetime of the individual. This means that for non-carcinogens, we assume that harm only occurs during active exposure and that the average daily dose over that exposure period is enough to evaluate potential health effects. This approach simplifies the risk assessment and aligns with how most short to medium-term exposures are evaluated. The ADD is calculated using this formula. ADD equals the product of concentration, intake rate, and absorption factor divided by body weight and multiplied by the ratio of exposure duration to average time. Let's break that down. Concentration refers to the amount of the chemical in the medium, for example, milligram per liter of water or micrograms per cubic meter of air. Intake rate is how much of that medium is consumed or inhaled per day. Absorption factor accounts for how much of the chemical is actually absorbed by the body. Body weight is used to normalize the dose, usually in kilograms. And finally, we adjust the dose for exposure duration and average time, both typically measured in days. This formula helps us estimate the amount of a chemical an individual is exposed to each day over a specific period of time. Now let's look at how we assess potential dose for carcinogenic chemicals using lifetime average daily dose, LADD. For carcinogens, we assume that even small exposures can contribute to cancer risk. So rather than only considering the period of exposure, we evaluate the dose averaged over a person's entire lifetime. Even if the actual exposure only occurred during a limited time, the biological relevant dose is still expressed over the lifetime. This approach helps us better estimate the long-term health risk of carcinogens and supports more protective regulatory decisions. Here, we see the full equation for calculating LADD, which is used when assessing the risk of carcinogenic chemicals. The LADD estimates how much of a substance a person is exposed to each day over their entire lifetime. It includes key factors such as concentration, which was determined from the exposure assessment process, intake rate, absorption, exposure frequency, and duration, and the person's body weight. All of this is then averaged over a standard lifetime, typically expressed in days. This approach helps capture long-term risk, even if the exposure only happened for a short period during that lifetime. Understanding LADD is essential when evaluating potential cancer risks from environmental or occupational exposures.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.